Hey everyone, I hope you're having some productive time with everything going on right now, getting some math in, learning some new things. Today we're going to be working with something called translations, and this is with lesson 1 of chapter 6, I believe. Yeah, chapter 6, lesson 1. And the first thing we're going to go over is something called a transformation. A transformation is an operation that maps an original geometric figure, which is called the preimage. So the original geometric figure is your preimage. I think you can see that decently. That's your preimage onto a new figure. Mapping that onto a new figure is called your transformation. And that image is just an image. It's just a new figure. That's your image. But your transformation is the operation that maps this. It moves this previous image onto a new figure or new image. In other words, this transformation is just moving or changing your previous image in some way. It's still going to look the exact same. It's just going to either make it bigger, smaller, move it over, rotate it, something where it's like moving it around or changing it in some way, but it's still going to look like the exact same figure, even if it's just turned or changed in some way. A translation is a type of transformation. So a translation is just a slide. It's just moving that figure. It just slides that figure from one position to another without turning it. So the object does not turn. It's just moving it up and over, or just up or over in one direction. It can do up and sideways, so it could be like 3 spaces up and 3 spaces sideways. But it cannot rotate. So I'm going to have you try and define that in your own words. List 3 characteristics. Draw an example and draw a non-example. And I'll go through one too. I'm just going to give you a little bit of time. I would pause the video right here if you were going to do this. So pause it, do this, and then once you finish up, start it up again, and I'll have an explanation showing some things. Alright, so if you pause the video, I'm going to go through this now. So defining it in your own words, I would just say moving a shape in any direction without rotating. So 3 characteristics, something we haven't really talked about, but it'll have the same angles, congruent angles, I should say. So same angles, congruent angles, congruent lengths, or the same lengths of their sides. So same length sides. And same, it'll be in like the same position. I don't want to say position though, because it's moving into a different position, but it'll be in the same, it'll have the same visual look, because it won't be rotated. Same visual look. So an example of this, I'm going to just try to freehand this to the best of my ability, but it'll be the same shape, and it'll be in the same position. It won't be rotated in any way. These will all be the same length. So these sides, it's all the same. It's just got moved up and over. A non-example would be the same shape. I could do the same shape, but if I rotated it, this one has been rotated, so this is not a translation. That is a non-example. Alright, so here's more on that. When a figure is translated, the x-coordinate of the preimage changes by a value of the horizontal translation A. The y coordinate of the preimage changes by the vertical translation of B. So this is just saying that however much up A went, that's how much everything else is going to go up. So this point went up here 1, 2 points, so it went up 2. So A went up 2, B is also going to go up 2, C will also go up 2. Then it went over 1, 2, 3. A went over 3. So up 2 over 3. Everything went up 2 over 3. That's what this explanation over here is saying. And then they're showing that with symbols, it's just saying up. So this is over 3. We went over, or over 2. No, 3. Over 3. So x plus 3. A would be 3 in this example they have here. And B, it went up 2. So y, x plus 3, it went right 3. Y plus 2, up 2. Up 2. Plus, because it went up and right. If it went left and down, it would be subtracting or adding a negative. So, if you need a little more explanation, you can go and rewind. Don't be afraid to rewind. Go back through things if you need more of an explanation. Or you can email me questions or Mrs. Stofflet questions, either one, and we can help you through things. But we'll go through some examples later on in this lesson. So when translating a figure, every point of the preimage is moved the same distance and in the same direction, just like I kind of was saying there. The image and the preimage are congruent. Congruent, we kind of been over this before, but congruent figures have the same shape and the same size. So same shape and same size. That is what congruent is. It'll look the exact same. It might be rotated. Congruent can be rotated or something like that. Translations cannot, but congruent can be. So it can have the same shape and the same size. It just has to be the same exact shape. Alright, so moving on. We can get into some examples now. So it wants us to graph this shape, JKL, with vertices -3, 4. It's just telling us where these vertices are. 1, 3, and -4, 1. So -4, 1, right there. -3, 4, right there. And 1, 3, right there. Then graph the image of JKL after translation 2 units right and 5 units down. Write the coordinates of its vertices. So, in this example, they moved everything over 2 units right. So J went over 1, 2, K went over 1, 2, and L went over 1, 2. And then 5 units down from that position, down 1, 2, 3, 4, I must have missed one, but 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Always went over 2 and then down 5. Order really doesn't matter because if you did down 5, right 2, you still be in the same position. As long as you go down right 2 and down 5 in some order. And then it wanted us to write the coordinates of this new image. So you can see they drew this image here now. And then after they plotted these dots down, they drew the image. And then from the graph, they looked at this, this went over -1, down 1. So -1, -1. That's J. K, 1, 2, 3, down 1, 2, 3, -2. L, 1, 2, -2, it's at -2, and it went 1, 2, 3, 4, -2, -4. And that's all there is to these problems. Alright, so I want you to try this got it here. Try it on your own, and then I will do this with you, try to go over it. I don't have graph paper, which is kind of a bummer, but I will do this my best freehand. I want you to use graph paper if you have it. Maybe I'll even use one of the graphs above to try and do it, but that might be confusing. I'll try to do it freehand. It's not going to look very nice, but it'll be an example that you can look through. So, pause the video if you need to do this and have some more time, and then I'll go through what to do for this. Alright, So it wants us to start with a graph. I'm going to do my best at trying to graph this with the little space I have here. Now, don't freehand this. Use graph paper if you have it. I do not have it with me right now, unfortunately. So I'm going to be doing this without graph paper, which is not recommended, but I'll do my best. So this shape is at 5, 1. 1, 2, 3, 4, 5, 1. That's for C. That's my C point. My B is 0, 2, 1, 2. And my A is 4, 1, 2, 3, 4, negative 3, 1, 2, 3, about right there. And that gives me a triangle. Now it wants me to go 4 units left and 3 units up. So I'm taking each point, 1, 2, 3, 4, and going 3 units up. 1, 2, 3. I'll be up in here. So that should be 1, 2, 3, 4, 5. 3 units up. So that's now at negative 4, 5 for that coordinate. For this coordinate, it'd be easier if I had graph paper. I kind of wish they would have had graph paper with this, got it. But 4 units left. 1, 2, 3, 4. I'm at 1 and 3 units up. 1, 2, 3. So it'll be at negative 1, 5. This is negative 4, 6. And then I'm at 5, 1. Go 4. Oh, I just did that one. I'm at 4, negative 3. I got to go over 4 and up 3. So I'll go from this 4. 1, 2, 3, 4. I'm at the y-axis and I go up 3. 1, 2, 3. So my new shape, it kind of overlaps this shape, is right here. My coordinates, so for A prime, you put a little dash right here for your new one. 4 units left, I'm at 0. Went from here to there, I'm at 0, 0. For B prime, I went from 0, 2, 0, 2. I went 4 over, so I'm at negative 4. And I went up 3, so I'm at negative 4, 5. C prime, I went from 5, 1 over 4. So I'm now at 1, and I went up 3, so 1, 4. Over 4, up 1, 1, 4. Up 3, this is at 4. So that's how these are done. Moving on to example 2. Triangles XYZ has vertices x at negative 1, negative 2, y at 6, negative 3, and z at 2, negative 5. Find the vertices of x prime, y prime, z prime. So this is just what the shape is after the translation. This just stands for the shape. New shape after translation. That's all that's asking for. Again, feel free to pause the video, go back and review things if you need to anytime if you're confused. Slow it down. You don't have to go at the speed of this video if it's too fast for you to understand. So our translation for this new shape is 2 units left and 1 unit up. Use the table add a -2 to the x-coordinate and 1 to the y-coordinates. That's what it wants us to do. So it's using this table they made, vertices of x, y, z. They put down all our vertices over here, and then they did -1. See, remember how in the past, we go back to these symbols, they added what the translations were right next to it. So with our points, we know we're adding this -2, that's our translation. Since it's left, it's a negative. And 1 unit up, we can add that 1. 2 is on the x-coordinate, so it's added to our x. We're going left and right, added to our x. This 1, this up and down point, is going up and down. It's on our y-coordinate, so we're adding it to our y. Up and down to the y, left and right, you add to the x. Left is negative, down is negative. So our first point they had was x, which is -1, -2. At -1, they added this -2 to it. That was our translation, was left 2. So they add -2 because it's left. For our y-coordinate, they had -2, and they add that 1 since we went up. Up is positive, we add the 1. -2 plus 1. Similarly with the next point, 6, -3, add the -2 to the 6, add the 1 to the -3. Add the -2 to this 2 for the next point, add the 1 to the 5, to the -5. So you're just taking your points and you're adding your positive or negative depending on if it's left or right. Left is negative, right is positive. So you're adding your translations to these points. Left and right are for your x, up and down for the y. And then that'll give you, once you simplify this out, -1 plus -2, you get -3. -2 plus 1, -1. Similarly, going through, you get 4, -2, and 0, -4. So the vertices of x prime, y prime, z prime are these points. They just put x prime, which is what this symbol means, -3, -1, y prime 4, -2, and z prime 0, -4. The new x, y, and z right here. So I'm going to have you try got it. You're going to make this table and add what the translations are. Try that. Pause the video right here and try that, and then resume it, and we'll go through it together. All right. I'm going to make the table. So I'll make the table over here and then move it over so you can see it after I get my information down. For these points, we're going to be adding 4 units to the x because it's moving right and left. That's x. And since it's right, it's going to be +4. So we're going to have x plus 4. And our y is going to be adding a -2 because it's down 2. So it's a -2. So y plus a -2. And that'll be our new point. And my table didn't turn out like perfect. That's okay. I think I'll still get across the idea. So our vertices are A0, 0. This is my A vertice. My B vertice is 2, 0. My C vertice is 3, 4. And as you can see, there's 4 for this one. It's not just a triangle. My D vertice is 0, 4. So at this point, I'm going to be doing this operation for each one. So 0 plus 4, 0 plus 4, and 0 plus a -2. Then I'm going to have 2 plus 4 and 0 plus a -2. Then 3 plus 4 and 4 plus a negative 2. And I'll also have 0 plus 4 and 4 plus a negative 2. And I know that's not the easiest to read, so I'm going to try and talk through everything because it's kind of small for this area I'm trying to write in. But this is also a little small. I'm going to put my answers down here. So if I simplify this out, A is going to be 0 plus 4 is 4, 0 plus negative 2, anything added to a negative is subtracting the negative, so 0 minus 2 is negative 2. My B value is going to be 2 plus 4 is 6, 0 minus negative 2, negative 2 again. C value, 3 plus 4 is 7, 4 plus a negative 2 is 2. My D value, 0 plus 4 is 4, 4 minus 2 is 2. So that'll be the points you'll get for this one. If there's any questions on that, feel free to email me or Mrs. Stofflet. We're always welcome to questions and answering those. Don't be afraid to ask us questions. That's what we're here for. This is our last example before this lesson is over. So hang in there. We're getting there. A computer image is being translated to create the illusion of movement. Use translation notation to describe the translation from point A to point B. So now we are describing the translation based on what we see. And it only gives us 1 point, even though there's a bunch of things moving. If we can determine how 1 point moves, that's exactly how the rest are going to move too for it to be a translation. So point A is located at 3, 3 right here. Point B is located at 2, 1. We have to figure out from x to y how our xy changes. So what they did here was they had 3, 3, and they did 3 plus some number and 3 plus another number got them to 2, 1. They wanted to figure out what these two numbers were. So A and B, what was our translation to get to 2? 3 plus A equals 2. They broke this down into algebra. 3 plus what number gave them 2? What number had them go down from here to here? 3 plus what number? 3 plus what number gave them 1 also? So 3 plus B equals 1. We're just trying to figure out how much this moved. Solving for A, they subtracted 3 on both sides. And got A is negative 1. They subtracted 3 on both sides on this one as well. B is negative 2. So what that told them is that this moved down 2 and left 1. So this is their point right here. This is where B went, which is correct. It went down 2, left 1. Negative 2 is down. So the translation is written in this notation. You have to write it in this notation right here. X minus 1, y minus 2. 1 unit to the left and 2 units down. So this is them describing what this means. 1 left, down 2. Subtracting. And I know I went through that a little bit fast, so if you need to go through that again, you can. Pause it if you need some time to think too. Our last got it for this. Refer to the figure in example 3. If point A was at 1, 5, use a translation description. Translation notation to describe the translation from point A to point B. So point A, going back to this, was at 1, 5. So that's just saying if we were at 1, 5 up here, how much did we change to get to B again? So we went from 1, 5, and we want to know how we got to 2. I believe it was 2, 1, right? Yeah. 2, 1. How did we get to 2, 1? To do this, we can set up our little algebra. So we did 1 plus a, we don't know what that is, and that's going to equal our new answer, 2. And then we had our y, so 5 plus b equals our new answer, which is 1. Solving for each of these, subtract 1 on each side. A equals 1. Subtract 5 on each side. B equals -4. So in our notation, this is how we write this. X plus 1, because it's a positive 1, and y minus 4, because it's a -4. So this is our translation. This is how we're going to describe this. Use translation notation to describe the translation. That is our translation right there. That is our translation notation. So it's saying we went right 1 and down 4. Going back to this, if we had this point right here, we went right 1 and down 4. 1, 2, 3, 4. And that got us to point B. This is point B. So that is correct. Alright, that is it for the lesson. We made it through. I hope it wasn't too bad for you. I think this lesson, with a little bit of practice, will start making sense. So I will also post down what our practice problems are going to be for this one. And I'll probably share them right now too. So for this one, it's going to be on page 457 to 460. So starting on this page right here. And you're going to be doing problems 1 through 7, 9, 18, and 19. So try those out. I will post answers for those tomorrow. Do your best on those. And I'll post the answers tomorrow for you to check. So give that your best shot. I hope this lesson wasn't too bad for you. I'll have another lesson out tomorrow as well as these answers. So there'll be another lesson out tomorrow. It's going to be similar to this one, a little bit of a different kind of transformation though. I hope you have a good night, and I will see you tomorrow with the next lesson.